Hello everyone. So in this video we will discuss about how to delete last node of a singly linked list. So here you can see that this is the algorithm to delete the last node of a singly linked list. So let's say we are given a singly linked list having these 3 nodes and we want to delete the last node of a singly linked list. So here the singly linked list can contain n number of nodes, and here if we take this example where head is pointing to a node having value as 10, 10 is pointing to 1, 1 is pointing to 11, and finally 11 is pointing to null. So there are 3 nodes, and if we apply this algorithm, when we call delete last, first 11 will be deleted and we will be left with 2 nodes, and if we again call delete last, then 1 will be deleted and we will be left with 1 node. If we again call delete last, then the only node left will be removed and simply returned from this method. So in our previous video, we saw that how we can delete the first node of a singly linked list. So there, as head pointed to the first node, it was very easy to delete the first node of the singly linked list, but here, as we want to delete the last node, we need to somehow traverse to the second last node and remove this link to delete the last node from the singly linked list. So in order to achieve that, what we do is, we create 2 pointers, one by name current, which travels to the last node, and one pointer by name previous, which travels to the second last node. So as current travels to the last node, previous travels to the second last node. And why we need the second last node? Because in order to free the last node, we need to break this linkage here. So we need to traverse somehow to the second last node, break this link to make this node free. So this is the algorithm for that. Now let's see the demonstration of this algorithm step by step. So when we call delete last for the first time, we first check whether head is equal to null or not. So head is pointing to this node, so this condition is false, and we also check whether head.next is equal to null or not. Now why we perform this check is because, let's say if the linked list has only one single node, so this node next will point to null and this will be the only node in the singly linked list. So we don't have to delete anything, we simply have to return the head, because this is the only node which we want to return from this method. So currently head.next is also not equal to null, therefore both the condition comes out to be false. And now, as we discussed, we create 2 pointers, current and previous. So we start current from the head by assigning the value head to it. So it would look something like this. And as head is pointing to the first node, its previous node will simply point to null. Moving ahead. Now friend, as we want to delete the last node, we need to provide a while loop so that we can traverse current to the last node of the singly linked list and previous to the second last node. So here if you see, in the while loop we are providing condition that iterate till current.next is not equal to null. So here when current will reach to the last node, its next will point to null. So this while loop will terminate when current.next becomes null. So as current is pointing to this first node and its next is not equal to null, therefore this condition comes out to be true and while loop executes. So before moving current to its next node, what we do is, we simply assign current's value to previous, so that previous is one node behind the current when current travels to the second node. So in the first step, we simply assign the value of current to previous, so it would look something like this. Now as current is pointing to the first node, previous will also point to this first node. And in the second step, we simply move current by one position by assigning current's next value to current. So current next is pointing to the second node, so now current will point to the second node. So here you can see, we have traversed current to the second node and previous is just one node behind it. So this is all we do in the while loop till current reaches to the last node and previous reaches to the second last node. So let's see how. We again check current.next is equal to null or not. So current's next is not equal to null. This condition comes out to be true. And before moving current to its next position, we make sure previous is at current's position by assigning current's value to previous. So it would look something like this. Then we simply move current to its next position by assigning current.next to current. So current.next is pointing to this third node. So after this assignment, current will point to this node. Moving ahead. Now friends, here you can see that we have these 3 nodes, but in single linked list there can be n number of nodes. So the only idea to delete the last node of the single linked list is we need a reference to the second last node of the single linked list so that we can remove this linkage. So now here you can see current has reached to the last node and previous is on the second last node. So here the condition current.next not equal to null comes out to be false because current next is pointing to null. So this while loop terminates, which makes sense because we have traversed till the last node using the current pointer and we also know its second last position using this previous pointer. So after this while loop, the next step we do is we assign a null value to previous next. And why we do so? Because we want to break this link so that this last node can be freed up. So previous is pointing to the second last node, its next is pointing to the last node, and we want to delete the last node. So we break this link by assigning null value to previous next. So it would look something like this. And finally, we return the current. So after the deletion of the third node, we are left with 2 nodes. So let's say we again call this algorithm. Head is pointing to the first node, so it's not null, and head.next is pointing to the second node, which is also not null. So this condition comes out to be false. We again create current in previous nodes by assigning head to current and null to previous. So it would look something like this. Current points to the first node and previous points to null. And then we provide a while loop because we want to traverse current to the last node and previous to the second last node. So first we check whether currents.next is equal to null or not. So currents next is this second node. It's not equal to null. So the condition in while loop comes out to be true and while loop starts execution. Before moving current to its next, we assign current's value to previous so that it is just behind the current. So it would look something like this. That now previous is pointing to this node because current is pointing to this node. And now we'll simply traverse current to its next position by assigning current.next to current. So current is pointing to this node, its next is pointing to the second node. So after this assignment, it would look something like this. And then again in while we will check whether current.next is equal to null or not. So here you can see that this singly linked list contains only 2 nodes and current is actually on the last node and previous is on the second last node. And as current next is pointing to null, current will be pointing to the last element of the singly linked list. So this condition comes out to be false and while loop exits. And now we'll simply assign null value to previous next because we want to break this link so that this node can be freed up. So it would look something like this. That null is assigned to previous next. Finally, we return current. So now we are left with only one node. So let's call this algorithm again. So here you can see head is pointing to first node, which is not null. So this condition is false. But head.next is pointing to null. Head.next is pointing to null, which signifies that singly linked list has only one element because head is pointing to the first node and its next is pointing to null. So therefore this list has only one node, and if we want to delete that, we don't have to do anything, we simply return head. So friends, this was the algorithm where we discussed that how we can delete the last node of the singly linked list. We also discussed that how current and previous pointers help us in deleting the last node, because in order to delete the last node, we somehow need to travel to the second last node, and once we travel to the second last node, we simply assign null value to its next so that the last node can be freed up and can be returned from this method. So friends, now let's go to Eclipse and see the demonstration of this algorithm. I hope you like this video. Thanks, have a nice day.